how we can solve polynomial equations. So on the board I've got the first one, which is find the roots for y equals 2x cubed plus 8x squared plus 7x plus 1. Now if we were going to solve this, what would we set the value of y to?
0.
Yeah, we'd set the value of y to 0. So we'd have something along the likes of roots when y equals 0. Nothing new just yet. Now, because of this, we have a few different options of how we could solve this. Now, first thing we're going to do is obvious. It's like, well, let's use the null factor law because it's a polynomial. But the question is, how do you get it into its most factorized form? From memory, we have 4 different ways we could do it. We could do it numerically using technology. That would be fine. Second one we could do is synthetic division. So if we know one of the roots, which we learned how to do last lesson, we can just get 1, and because it's third order, we can just use synthetic. Next one, we can use polynomial or algebraic division. Exact same thing. You simply know one of the roots by guessing, and then you can just factorize everything. And then the final one you could do is algebraic factorization. Now from these, the quickest one is probably the first one. Second fastest, third fastest, and fourth fastest. But it's all a matter of which one is going to be the most efficient way, which one will yield the answers the easiest. Now when we're doing this, we're going to have, obviously, 0 equals, does anyone want a marker?
Yeah.
It's not great. 0 equals 2x cubed plus 8x squared plus 7x plus 1. Now looking at this, are there any roots that we can see straight away?
One.
Yeah, probably 1. 1 could be a root. Is there any way on a polynomial like this that we could definitively say the roots are going to be, at least one root is going to be? Could we use any tool?
Technology.
Yeah, what we do is we start off with these ones by using technology. So we bring our calculators up and we have to go into run matrix mode. We do this top screen, just hit 1, and we'll clear all of that memory because it's a new question. Okay, now it's a matter of using solve n. So options, calc, and then solve n. From there, we're going to type in our equation. So we're going to go 0 equals, and then 2x, x to the power of 3 plus 8x squared plus 7x plus 1. And we have to tell it to solve for x. Closing this off, tells us there's going to be more than one solution, some of which might not be listed. And lo and behold, we have negative 2.8, so we've got an irrational one, we've got a rational one of -1, and then we've got some other one. So we know that there is a root at x equals -1. Is that cool? So if we were going to factorize this then, hence x plus 1 is a factor. Does that seem alright so far? Now, if we had completely rational roots for each of them, then we'd be able to get away with simply using all the answers that the calculator gave us and writing it out as the product of factors, and then we could just use the null factor law to state them. But because they're irrational, we have to go into some other form of factorization. What we would be expecting is that y equals, or I'll say 0 equals, x plus 1, and then we're going to get some other second order polynomial. Now, it's at this point we could expand that, we could use inspection, and we can determine the coefficients of A, B, and C, but there is a faster way. Because we have a linear factor over here, rather than going down the path of slowest solution, we can pick one of the quicker ones. What would be available to us? We can't use this, we can't use this. Synthetic. Synthetic's going to be our second fastest. Because of this, our K value is going to be what? Please, Mad Dog?
-1.
-1. Excellent. So it's a matter of -1. Then we go back up to this polynomial. 2, 8, 7, 1. Solve. 0, 2. Then -2, 6. Then -6, 1. Then -1 and 0. So we discovered that our polynomial is going to be x plus 1. And then the coefficients in here are going to be 2x squared plus 6x plus 1. Okay, next step. What could we do to be able to get this in a fully factorized form so we can use null factor law? What tool do we have available? Are there going to be rational roots here? No. Are they going to be real roots?
Yeah.
Yeah, they're going to be real roots because our calculator told they will. So how can we actually find the roots if they're not rational?
Completing the square or quadratic formula.
Yeah, complete the square or you can use quad formula. What one do we want to use today, Mad Dog?
Completing the square.
Okay. Okay, we want to complete the square. So what we're going to do is
Second challenge.
x plus 1. It's alright, the next example we can use the quad formula. Then
See.
pull out the value of 2.
So,
X squared plus 3x plus a half. Next, we're going to go x plus 1. Next line of working out, we've still got the 2 there, and now we need to halve the linear term.
stretching.
X squared plus 2, we get 3 on 2 in there, x. Now we need to give a square factor of the linear term, or half the linear term coefficient, so it's going to be 3 on 2, all squared, take 3 on 2, all squared, plus the half. Next, we'll put it down here I guess, x plus 1,
You are.
2, and then we have that part in there is our perfect square, so we're going to have a perfect square of x plus 3 on 2, all squared. And then,
What's the point of doing completing a square when you can just use the quad formula?
Completing the square is so much more fun.
to be fair, I feel like I'm losing myself a little bit here, but that's alright. I'm not sure if this is going to work.
Should we just use the quad formula?
I think we should just use a quad. Well, yeah, we can, but we could go down this way, but then we've got to build another equation
Yeah.
and then solve for the roots in here. I mean, we can if you want, but it's not the most efficient.
Yeah, no, we go with most efficient.
Okay, let's. I'm glad you said that, Rowan.
Yeah.
Madden, do you mind if we go with Rowan's idea this time?
Fine.
Okay, using quad formula. Oops. Do you have to communicate you're using the quad formula?
Yes.
Not really, but it's good practice because it tells the marker that you've used a more efficient manner. Okay, using the quad formula, we go back to our technology and then we use some macro functions. So we're going A, B, C. So it's going to be 2 into alpha A. It's going to be 6 into alpha B. And it's going to be 1 into alpha C. Next, we type in the formula. We're going for a fraction. it's going to be negative b. Please remember to do the negative, unlike what I did last lesson, and spend 2/3 of the lesson figuring out why my roots were the opposite. B squared minus 4ac all over 2a. I feel like that was much more efficient. So we discovered that our roots are going to be at minus 3 plus root 7 all over 2, and then the opposite root is going to be at the minus 7. So when we put this all together, it's going to be x take, then it will be negative 3 plus root 7 over 2, x take negative 7 take root 7 all over 2. Therefore, x equals to get x equals 0 using the null factor law, we're going to get minus 1, and then we're going to get negative 3 plus or minus root 7 on 2. So the idea was to look at how we can solve polynomial equations, and in this example we simply said where are the roots at, which turns it into an equation, and then we solve. This method we chose to start off using numerically, but we found out 2 of our roots were irrational. So because 2 are irrational, we can pull out the rational root. We can go down the path of synthetic division. After synthetic division, we then factorize this guy. We factorize it using the quadratic formula, and then we use the null factor law. Might switch to blue on the next one. This one's a bit spent. Does that seem okay for now? It's basically the same as last lesson, isn't it? Okay, here's what you haven't seen yet. Can I erase this?
Not yet, 2 seconds.
All right.
My sister's doing flips. Yeah.
Right.
Yeah, I was just thinking you were back.
I don't think it'd be good, but I wouldn't be surprised.
No, she's doing power.
We ready, Ron?
Yeah.
That would make more sense.
I'm good with that. Alright.
We're really into that for a bit.
Yeah, it's actually pretty good. And you're back.
Yeah.
Your brother's okay. What? No, I can flip it. You go back to it.
No, I need like a mattress or something. I don't know,
You're not going to
yeah.
back in front.
Yeah. My front's easy.
Down front.
Nah, I haven't tried that.
Ooh, scary.
I like back flipping more different.
You want?
I like back flipping more different.
Oh yeah, it's easier because you like, your momentum goes.
Okay, here's our next one. We will solve.
What's the better imaginary? Yeah.
We want to solve 6x cubed minus 5x squared plus 4x equal, or minus 15 equals 0. What should we first do if we're trying to solve this? What method are we going to go for eventually?
Probably calculator.
The null factor law. Null factor law, we start off by saying, can we solve this numerically? So, what do we reach for? Excellent. Now, before you go for your calculator, we have to do something to it. we're going to go options, and then we're going to press menu. No, we're not going to do that. We're going to go shift, and then we're going to press menu. You need to go down, and you're going to look for the thing that says complex mode. I'm pretty sure I got you to set it before, but just in case, make sure you're in complex mode.
Oh, mine's in real.
If you're in real mode, it's not going to work later on. We give you a math error, so just make sure you're in complex.
Will that affect any other, like if any other maths? Or should we just always stay in complex mode? Like
When you're doing your math methods, just switch it back into real mode because you don't do complex numbers in that subject. Okay, what we're going to do is we're going to do exactly what we did last time. Options, calc, options, calc, solve n, and then we input our polynomial. 6x cubed plus take 5x squared plus 4x take 15. You should put in the comma, whoops, that equals 0. It'll still solve it for the roots if you don't, but it's good practice to put in the full equation, and we're solving for x. Now, this one's a bit strange. It only gave us one root.
Maybe.
Yeah. Oh, yeah.
Did you actually?
What's happened?
Why didn't you ever say did?
What?
I grew up with imaginary
The calculator tells us there is a singular real root
Finding your best angle.
at x equals 3 on 2. What about the other two? This is a third order polynomial. Why is our calculator not telling us where the other roots are? They're imaginary roots. Whenever you have an imaginary root, your calculator cannot solve for it, or at least this model can't. So we only can take the real roots. Now, because we know the real root, we know that there will be a factor at. In this case, it's going to be x take 3 on 2. Now, I'm going to modify this slightly. We can take out the factor of a half, and we're going to get 2x take 3. This is what we care about for now. Now, there's two ways we could go about this. We could go what typically would be our fastest way, which is synthetic division. However, if you use synthetic division, you cannot use it with this factor here. It only works with this one. However, if you chose to do that, you'd be doing synthetic with fractions. Nice?
No.
No. Next fastest way is we can use polynomial or algebraic division. The advantage of using this one is we could do that, or we could do this one. This one's preferred. So which way do you want to go? Synthetic or algebraic division?
Algebraic.
Good answer. If you said synthetic, I'd say you can do that. Tell me how you go. So what we're going to do is we set ourselves up. Our factor is going to be this one here. So we're going to go 2x, take 3. And then, this is our divisor. This is our dividend. 6x cubed minus 5x squared plus 4x. Okay, 15. Do we all remember how to do algebraic division? Or polynomial division? Kind of. What do we need to multiply 2x by to turn it into 6x cubed? 3. So that will be 9x squared. Go for the subtraction. Nothing to do here, it's zeroed out. That will be plus 9, so it'll be 4x squared. Bring down the 4x. What do we need to multiply 2x by to turn it into 4x squared?
2x.
2x. That's going to give us 4x squared. That's going to give us negative 6x. Is that correct?
Yeah.
Good. This will be 0. This will be 10x. Then bring down the minus 15. That's going to be, what do we multiply 2x by to get 10x plus 5? Do we have to finish this?
No.
No. This is just a tool we use to factorize. We don't have to finish that. I mean, we could.
Get your closure.
It's cathartic. And then I've just wasted board space. All right, so what we discover is that the quadratic factor is going to be 3x squared plus 2x plus 5. So when we're doing this, be really careful because we're doing something that if you're not careful, you might bamboozle yourself.
Is there not a half? Do you put the half in front of it?
I like the fact you said that, Rowan. Why did I choose to leave the half out?
Because it doesn't matter for solving for null factor.
Yes, it doesn't matter, but also, what did I divide this polynomial by?
2x take 3.
2x take 3. If I divided it by that, then I'd have to put the half in there, but I didn't. I just
Made it
knew
much harder.
2x take 3 is a factor. We don't really like dealing with the a out front of our factors, so ignore it for now and then work on it at the end. So don't worry about those coefficients till the very end. So this is our polynomial here. We've got a quadratic. What method do we use to factorize quadratics?
Quadratic formula.
Quadratic formula.
I think it's going to sound better. Trust.
But it's not the most efficient.
Yeah.
Who cares about efficiency when you have a fun?
CT3.
Yeah, man.
Oh no.
Yeah.
Damn.
Or is it CT2? I can't remember.
It's one of the seasons.
It's one of those two. It's about efficiency.
Have you ever had a CT scan experience?
No, I have not injured myself enough to get or need one of those. Okay, so we go for our calculator. We make sure that we are in complex mode and we simply type in. Whoa. What's that? Sorry, of course. We type in our values. So we're going to go 3 into alpha A, 2 into alpha B,
Now when you jump and
and 5 into
Yeah.
alpha C.
left and right, that's
Roll, maximum effort.
maximum effort.
Maximum effort. Okay, negative b plus the square root of b squared take 4ac all over 2a. What sort of roots are we expecting?
Imaginary.
Imaginary. Or we're expecting complex. So we can see that our roots are negative 1 over 3 plus I root 14 over 3. And what's the second one going to be?
Negative 1 take square root 14.
Yeah, it's in a conjugate form. So there's no need to calculate the other one. Okay. Putting this together, we can go x take, and then it's going to be negative, negative 1 all over 3 plus I root 14.
Does it matter which order you do it with the guys at the end of the start?
No, the order doesn't matter. No, it's 3 over 2.
And it also doesn't matter if you put the negative 1 and 3 by itself, Or join?
No, it doesn't matter. I just like having them together. Okay, so in summary, we've learned how to solve polynomial equations. We have 4 different ways we can go about it. We should always try and use that technology to begin with. This will reveal to us all of the real rational roots. It will also tell us the irrational ones, but there's not much to be done about those. Once you know at least enough roots to reduce it down to a quadratic, you can use your tools such as synthetic or algebraic division to move it into its quadratic form, and then null factor law. Or if you really need to, you can use algebraic factorization.
Do the roots of the negative ones change because it's x take -1? Like, do the roots, do the negative ones become positive?
These negatives or these positives here?
Yeah, those negative ones.
Yeah, so if you wanted to expand this out, you could turn that into a 1 take I root 14 all over 3, and that would become a 1 plus I root 14 all over 3. The reason I choose not to do it like that is because, remember, we're trying to solve the equation here. We're not trying to find the factorized form, we're just trying to solve the equation. So if you leave the root in the bracket, there's less double handling and less chance for error, like human error. Does that answer your question?
Yeah.
If it said what are the factors or fully factorized, then you would, if you chose to, get rid of the brackets and bring the -1 all the way through.
Yeah.
Yeah. Did anyone else have any questions? So this is comprehensive for anything we can be given in solving polynomials.